All right, this is for competency 1B in chapter 20. This whole competency is about balancing your redox reactions if they are in an acid or a base. And so we're going to take those skills we had on comp 1A where we were balancing half reactions and we got their electrons equal, and then we're going to add a few steps to them. So after we get to the point where their half cells are equal, we're going to put them back together. Their electrons will cancel, we'll put them back together. From there, you are always following these steps, no matter if it's an acid or base. It's just where do you stop? It's going to be different. So before this point, before adding them back together, the only things we worried about balancing was the actual element that was reduced or oxidized and the number of electrons. Then we're going to put them back together, and we're going to look for oxygens. And if our oxygens are unbalanced, we're going to start adding waters to balance them out. After that, we've introduced hydrogens. So we are going to add hydrogen ions to take care of any imbalances between hydrogens. If it tells you you're in an acidic solution, at that point you're done. You stop. If you're in a base, you have to keep going. So if you're in a base, we can't have hydrogen ions floating around. That's a telltale sign of an acid. We need hydroxides. So you would add hydroxides in to cancel out those hydrogen ions. Well, you don't want to mess up your balancing. So however many hydroxides you add to one side, you have to add to the other. So make sure you're adding them to both sides. And that's in order to cancel out the hydrogens. And that's only going to happen if you are in a base. From there, if you're in a base, you have to do this last step. You've created some new waters. Like when these two get together, they're making waters. You would want to look on the reactant side and the product side and cancel out any waters that you have, just to simplify it up as much as possible. So again, if you're an acid, you're going to stop after step 3. If you're a base, you're going all the way to step 5. And so these are the steps I'm going to be referencing as we do problems. The problems we're doing, I just got them off the internet. I typed in balancing redox reactions in acids and bases worksheet, and the answer keys down below too. So if you need more practice, just do the same thing. Notice these are all in acid, so I'll do 1 or 2 of these, and then I'll do a couple in the base, and then hopefully you feel confident about it. All right, so every year in your final, you usually have one problem where you have to balance it, and it's in an acid or a base. Okay, so the first thing we're going to do is our oxidation numbers so that we can split our reaction up. So go in. This is a 2, oxygen's a -2, bismuth is a +5, oxygen's a -2, manganese is a 7, bismuth is a 3. So I can see bismuth went down. It was reduced. It went from 5 to 3. There's our rig. Our oxidizing agent would be this. Just recap, reminder. This manganese was oxidized. It went up from 2 to 7. So our reducing agent would be this, right? And now I'm going to split them up, balance them, get their ends equal, and then put them back together and do these steps. So everything I'm doing right now, we've done before. So oil, rig. All right, so I'm going to do oil first. It's losing electrons. So Mn2 is going to go to Mn O4 negative plus some electrons that it lost. And then I only look at manganese. Do not worry about that oxygen right now. So I'll have 1 over here, 1 over here. All right, so it's balanced. For it to go 2 to 7, it must have lost 5 electrons. When I go to rig, I'm going to do BiO3 negative plus some amount of electrons, right? Gives me Bi3 positive. So I'm only looking at bismuth because that's the thing that was oxidized. 1 of them, 1 of them. So that's good. For it to go to 5 to 3, it must have gained 2 electrons. So this isn't going to work for us. We need our electrons to be equal before we can put them back together. So 2 and 5 can both go into 10. I'm going to multiply this whole reaction up here by 2, 2, 2, 10. Multiply this whole bottom reaction by 5, 5, 10, 5. So N equals 10. That'll be useful to later comps. I'm just trying to get you used to identifying. And I can now see that my electrons cancel. So 10 electrons on the reactant side, cancel out with 10 electrons on the product side. So I've done step one. I balanced half cell reactions. We've done that before. Now we're gonna put them back together. So everything on the left side of the arrow, I'm gonna put back together. Okay, I'm not including those electrons, they canceled out. That'll just be more to write. And this is where I'm at. And so if there were no oxygens, we'd be done, but there are oxygens. We also know we're in an acid. They have to tell you, you can't just guess, is it an acid or a base? So that's gonna help us with these steps. So no matter what, whether you're in an acid and base, step 2, add water to balance your oxygens. So look over here, I have 15 oxygens. Look over here, I have 8. So I need more oxygens on this side. I need 7 more. So I'm gonna add 7 waters. So now that's 8 oxygens plus 7, that's 15. It cancels out those 15. Now I've introduced hydrogens. So next step, no matter if you're an acid or a base, add hydrogen ions. So there's no hydrogens over here, and on this side I have 14 hydrogens. So I'm gonna go to the opposite side and I'm gonna add 14 hydrogen ions. Now notice it told you you were in an acid right here. The very beginning. When we're in an acid, stop. You are done. This is your final answer. This is the balanced redox reaction in an acid. If it was a base, we would keep going, but it's not, and we can see it's in something acidic because we have all those hydrogen ions. And again, if you print this sheet up from the internet to try some out, you have your answers down here at the bottom to kind of check before you jump into your comps. So let's do another one. We'll say it's in an acid. I'll probably pause it and give you some time to work it out, and then just at the end I'll explain my steps, and then we'll go into bases. All right, so here's our reaction. It's going to take place in an acidic solution, so let's try this out. Pause the video. Try all the steps we just did. It's for an acid, so just stop early and then come back and compare. All right, so hopefully you're able to get this far. You assigned your oxidation numbers, you split them up, you balanced your chlorines in each one, and then you canceled out your electrons. You put it back together and we're here, and this is where the new steps occur. So next we're going into oxygens. There are 6 oxygens over here and 4 over here. So no matter what, we always add waters next. That'll count for 2 waters. So now we have 6 oxygens, 6 oxygens. Now I'm going in, I'm gonna take care of my hydrogens. There's 4 over here, none over here. So I'm gonna add 4 hydrogen ions. And that's it, you're done because you're in an acid. So the next problem we do is gonna be in a base. We're just gonna have some additional steps and then we'll stop and you can try one on your own too. All right, so we're gonna start off the same as all of the others. This time you can just see the only difference is we're in a base. Go ahead, assign your oxidation numbers. -2, 3, 4, -2, -8. Okay, so if I look here, it looks like my oxygens stayed the same, so they're not oxidized or reduced. So I'm looking at TEs and I'm looking at nitrogens. So TE went from 0 to 4, it went up in value, so it was oxidized. Nitrogen went from 5 to 4, so it was reduced. And I'm gonna split them into my oil rig. All right, so TE lost some electrons, not sure how many just yet. We'll do that in a second. And then my nitrogen gained some electrons. Okay, so looking at TE first, I'm asking myself, are they balanced? 1 and 1, yep. So for it to go from 0 to 4, it must have lost 4 electrons. For nitrogen, I have 1 over here and 2 over here, so first I'm gonna balance them. And now when I think about their electrons, it went from 5 to 4, so that's gaining 1 electron, but it did it twice because there's 2 of them. So 1 went from 5 to 4, and so did the other, so this should be a 2. Okay, now my electrons aren't equal, so I'm going to go ahead and get them equal. I'm going to multiply this whole bottom one by 2. It's become a 4, and a 2. And so now I can see that my electrons can cancel, and just remember n equals 4 for later. We are going to put these back together. So Te plus 4 nitrates, it's going to give us TeO3 negative 2 plus 2N2O4. Now we're in a base, but it doesn't matter. We're going to start the same as last time. The very first thing you're going to do is you're going to add waters to balance your oxygens. So I have 12 oxygens, 3 plus 8, so I have 11 over here. So I just need to add 1 water. All right. Now I need to balance my hydrogens. No hydrogens, 2 hydrogens. So I'm going to come over here and I'm adding 2 hydrogens. So that's the same as the acid. See, add hydrogens to balance them. If you are an acid, you're stopping. So this is where it's different. We're in a base, so we're going to keep going. So now I can't keep those hydrogens floating around. That makes something acidic. I'm in a base. So however many hydrogens I added, that's how many hydroxides I'm going to add. I'm going to make sure it happens to both sides. So I need to get rid of these 2 hydrogens. So I'm going to add 2 hydroxides. Well, I don't want it to be unbalanced, so since I added 2 over here, I'm going to add 2 over here. Okay? And so the last things we have to do is we just can't keep it like this. So anytime you have hydrogens and hydroxides together, you're going to combine these. 2 hydroxides plus 2 hydrogens become 2 waters. And so now you can see we're not really worried about the hydrogen ions in a base. Why is it a base? Because of these hydroxides over here. The last thing you have to do is you have to cancel out waters. So some of your questions might say, like, how many waters are on the product side? If you put 1, you're going to be incorrect, because one of these waters can cancel out with one of these waters. And so that's what we have to do last. That water goes away, and one of these goes away. So our final answer is 1 water plus Te plus 4 nitrates gives us TeO3 negative 2 plus 2 of these plus 2 hydroxides. And that's what you do if you're in a base. So let's try another one in a base. All right, take a look at this. Get all the way to the point where you add the reactions back together, and that's where I'll pick it up. So pause it, get to that step, and then when the video restarts, that's where I'll be. Okay, so we're picking up right here, and you can see all the numbers and everything I assigned above. Going to my waters first. I have 7 oxygens and 0, so I'm going to go ahead and add 7 waters. Next I'm going to do, and remember I'm in a base, but the first few steps are the same. I have 14 hydrogens, no hydrogens, so I'm going to add 14 hydrogen ions. Cannot keep it like that. I'm in a base. So however many hydrogen ions I have, that's how many hydroxides I'm going to add. I'm going to add that to both sides. So if I put 14 hydroxides here, go to the other side and add 14 hydroxides. And now let's think about waters and canceling them. So these 2 things are going to become 14 waters. Right? The last thing you're going to do is you're going to cancel out your waters. So I have 14 on this side and 7 on this side. So all 7 of these will cancel out with 7 of these. So at the end, I'll only be left with 7 waters. 7 waters plus 3 mercuries plus this dichromate gives us 3 mercury ions plus 2 chromium ions plus 14 hydroxides.